So thank you very much, first of all, for this opportunity to talk about a kind of business perspective, what we do to control mycotoxins and aflatoxins specifically. Firstly, recognising that this is a very complex dynamic between food safety issues, food security issues, climate change, poverty, the environments that we find ourselves. And so what's a solution in one part of the world is not a solution in another part of the world. And frequently we see in our factories in Europe a rejection rate of somewhere less than 1% for inbound testing for aflatoxin. And in other parts of the world, that can be upwards of 70%. And clearly there's a huge difference in the effectiveness of food safety regulation and food safety strategies. There's very few people in the room probably get really excited by this rather kind of boring diagram, but I do. This is a quality management process, and quality management processes mean that we get to drive them through our business, and we get conformity. It's the kind of internal regulation. And what we do is we get a group of really experienced individuals, bring them together and capture the best thinking that we've got in the business and the best experience across all our businesses and pull it together into one process. This material quality management process starts off with a risk assessment, and that's that kind of vaguely kind of purpley coloured thing that's not got any detail on it. But by going into each raw material, and specifically for the region from which it's sourced, you get a very specific understanding of those risks that are involved. And based on that, you can come up with a material specification. Based on that, you can talk to vendors, you can do the assessment, you can get approval for the specification. Once the specification is improved, you can go back to your vendor and you can start working with the vendor through a kind of continuous improvement process to make sure that they can comply with that specification. Now, this sets up a very positive interaction where if the specification is not met, you can reject on the basis of that specification. And that works well for business mostly. It's a bit more difficult with aflatoxins. If you really want to understand the aflatoxin risk, you have to do a very thorough vertical dive into the supply chain. You really have to understand what's going on in the field. What are the risks? How much aflatoxin is there in this season's harvest? And based on that risk assessment, you can then know what you need to look at harvesting, what you need to do during storage, and most importantly, when it comes to the factory, what are the interventions that you need to make? They should be risk-based. If you always operate to the highest level of risk, it's not very financially effective and it's not necessary. So based on that risk assessment, you tailor your intervention, which is very important, I think, for a meaningful and sustainable approach. This is what mycotoxins, and specifically the peanut and the maize are aflatoxin, the cocoa and the coffee are ochratoxin, and sorry, I use aflatoxin and mycotoxin interchangeably. We're primarily concerned about aflatoxin. That causes us the biggest issue. And there you can see a pretty green-looking peanut, obviously not a normal peanut, obviously easily recognizable, and maybe with a significant level of aflatoxin. However, I could have shown you a picture of a very normal peanut, not visibly moldy, not looking that much different from your standard peanut, that might have a very considerable level of mycotoxin too. And sometimes insects can bore inside seeds, peanuts, and create an opportunity for mycotoxins to be formed, aflatoxin to be formed. You can't tell simply by looking at the material if it's going to have a significant level of aflatoxin. So what you have to do, you have to test. Now, I became a microbiologist a long time ago. One of the things that drove me into microbiology was I wasn't really that good at maths. And unfortunately, it seems to chase me wherever I go. And there's a very complicated set of statistics. And if I can just draw your attention to the operating characteristic curve, which is the kind of slopey blue line, and that says that to have a 95% chance of detecting a 1% contamination rate, you have to take 300 samples. 300 samples. And that assumes a low density, random distribution. If it's a high density distribution, you're much more likely to detect it. But a low density random distribution, that's what you need to do. The statistics don't work for clumped distributions. One's a binomial, one's a negative binomial. If you talk about negative binomials to people who are really good at maths, they look really, really worried and get very confused, and it gets very hard very quickly. So it's actually really hard to detect a clumped distribution, and that's what you get with aflatoxin. So when you look up the figure on the left-hand side, and that's representing a truck, this shows you how we sample a truck. And we sample very well, we sample very thoroughly. In terms of industry practice, this is right up there. But not everybody can do this. And if you look at the operating characteristic curve, sampling alone doesn't give you a high probability of detection or confidence that you're controlling the issue. So sampling and rejection, well, sampling is not the answer because it's not very reliable. Rejection is not the answer because it's not very sustainable. We're doing a lot of research in this area, and we've got a couple of papers hopefully coming out with some very bright people from IBM in the not too distant future. How do you make a difference? I've talked about the context of a business, the context of how we operate. And that's relatively easy. We've got four walls, we've got a factory, we've got things coming in, we've got things going out, we have our standards, we have our processes, we have our people. But it's not the answer, it's not enough. By establishing a relationship with a customer, with a supplier, through the specification, we start a great conversation and we start an understanding. That sometimes can be enough, and we can walk away and we know that the right things will happen. But in many places, we know it's not enough. And so how do you take one supply chain and how do you leverage the things that you apply to that supply chain to make a difference across an agricultural system? And that's the big question. What we recognize as a business is we can get pretty good at sorting out what's good and what's bad. But, throwing things away, so taking off, the good material, putting that into our products, rejecting the bad material is not sustainable, particularly when you've got very high levels of bad material coming into a factory. Effectively, what you're doing is creating one part of the supply chain that appears to be clean and free of aflatoxin, or at least reduced risk of aflatoxin, and perhaps concentrating materials into other parts of the supply chain where the same measures aren't in place. Clearly not acceptable, clearly not sustainable. So what we've got to do is collaborate, and collaborate with a wide range of people. We're talking with GAIN, for example, and the Business Platform for Research. We're hoping to create some interest around aflatoxin there. We're part of the World Bank GFSP efforts, and I think there's potentially some interest in working on aflatoxins there. Certainly, we're interested in doing that. But we believe that we've got to increase that leverage so we can move away from thinking about, just being a supply chain to impacting an industry to impacting society. And how we magnify that impact is the key discussion for us as a business. That's me, really. I just wanted to share that perspective with you. Hopefully that was interesting and helpful. There's a little bit more in the document, and if you've got any questions, I'd be absolutely delighted to answer them later.